Hey guys, the objectives for this video is to find the stress increase at a point outside a rectangle. Okay, so before we looked at inside, now we're looking at a point outside the rectangle. So let's say we had our foundation, which looked like this. So our foundation was, say, 10 meters by 2 meters. Now we're interested at a point O, and O is out here. As I said before, we're always concerned about corners. So what we're going to do is we're going to construct the remainder of this shape to form another new rectangle. So what we do is we construct a new shape, keeping in mind that our actual foundation is just this area here. That's the foundation part. This area is surrounding it, but we have to, in order to do these questions, we have to form rectangles which have corners at O. And we're going to see now how we're going to split this up. So this is, say, 1 meter, and this is, say, 1 meter. So this point is 1 by 1 meter from this corner out. Let's just make up names for this. Let's call this, say, A, B, C, D, E, F, G, H. Okay. Let's say also that the pressure was 100 kPa and that the depth we're at is 1.5 meters. So how are we going to split this up? It's a bit more confusing now. The way we're going to do it is that every time we split up a rectangle, it has to have a corner at O. So every time we do this, we have to have a corner at O. That's the first thing. And the second thing is the only place where pressure is applied is only the foundation, which is this area here. So what we're going to do is we're going to go this total shape, so EOHD, because that's got a corner at O, minus this shape EOGA, which also has a corner at O, minus OFCH, because that also has a corner at O, and that gets us back to the actual part where the pressure is only applied, which is ABDC. But another thing is that because we've subtracted this shape and this shape, we've subtracted that shape twice, which isn't fair. So we have to add that shape back on. Okay, so once again, every shape must have a corner at O. So if we were, if you were to think of just going EOHD and finding that, it wouldn't be fair because the pressure isn't applied over this area, down this area. It's only applied over this area, right? So we need to consider shapes at corners and where the pressure is actually applied, which is only this rectangle here. So if I were to do this, we would do the entire rectangle, so EOHD. So EOHD, which has dimensions of 3 meters and 11 meters. So we'd go ahead and find M, which should say be 11 on 1.5, and N being 3 on 1.5. This would give us 7.33, and this would give us 2. We then come to our graph. So we have 2 and 7.33. So 2 is down here, 1, 2, up 2. This is, the last curve here is m equals infinity, and the curve before that is m equals 3. So we're pretty much at m equals infinity, which is around there. We dash across and we get a value of about 0.24. So I equals 0.24, and the change in stress would equal 0.24 by the stress, which is 100 kPa, so we'd get 24 kPa. So we've found this whole shape, which has a corner at O. We're now going to find EOGA. So if I find that, guys, if this is a bit confusing, just stick with me. We're going to find all these shapes, and then I'm going to explain it one more time after. So let's just do the numbers for now, and then we'll worry about what it actually means in a sec if you haven't got it yet. So EOGA. Once again, you notice that one of my corners is at O, which is important. So this is 11 by 1. So M will equal 11 over 1.5, which is 7.33, and N will equal 1 over 1.5, which is 0.66. If we come to our curve, so we have an N of 0.66 and an M of 7.33, so 0.66. So 2, 3, 4, 5, 6, 6 is say around here, and 7.33 would be all the way up here, because this is about infinity. We come across, and we get around 0.20. Okay, so we have I equals 0.2, which means that the change in stress would equal 0.2 by 100, which is 20 kPa. Okay, so that's this shape. So we found this big shape, this shape. We're now going to go ahead and find OFCH. Okay, so OFCH has dimensions 1 by 3. So M equals 1 on 1.5. N equals 3 on 1.5. So this would equal 0.66. This will equal 2. Once again, if I go to my curve, so N is 2 and 0.66. So 2 and 2 is down here, up to 0.66, which would be around there. Dash it across, we get around 0.16, say. So I equals 0.16, which means the change in stress would equal 0.16 by 100, which is 16 kPa. Okay, now let's look what we've done. So we've found, if I were to use red, blue, green, so we've found the entire area. We've subtracted this area, we've subtracted this area, and we've done that because they all have corners at O. But because we've subtracted this area twice, we need to add that back on, and when we do that, all we're left with is the actual pressure over this rectangle, which is all we actually have the pressure over. Okay, so we need to add on OFBG. So OFBG had dimensions 1 by 1, which means that N will equal 1 on 1.5, N will also equal 1 on 1.5, they both equal 0.66. Okay, I'm not going to do it. If you go to our curve, you're going to get an I value of around 0.125, which means that the change in stress is 0.125 times 100, which is 12.5 kPa. Okay, we can then find the total stress. So the total change in stress will equal just all the components. Okay, now this one is added. If we add that, then we subtracted this, we also subtracted this, and we added that. Okay, so it's important those signs. Big one, the whole one, minus this one, adding this one gets us back to where the pressure is actually applied, and all our rectangles have corners at O. So it's going to be 24, which is positive, minus 20, so minus 20, minus 16, plus 12.5. Okay, if we go ahead and work this out, we get an increase of only 0.5 kPa. Okay, so it's quite a small increase, but we get an increase of 0.5 kPa. Now, just one more time trying to explain this, it's quite confusing. The two important things we need to worry about for when we're at a point outside a rectangle is that all our rectangles have corners at O, and at the end of the day we get back to a pressure region which is only where our pressure is applied, which is this foundation, A, B, C, D. Okay, so if you would have thought of just going E, O, H, D, okay, because you still have a corner at O, and you would have worked the M and N for that, it's not right because the pressure is not applied over this region. Okay, so what you have to do is you have to split it up into, like I've done it, you have to find all your corners at O, and the only way of doing that is going E, O, H, D. Okay, you couldn't use A, B, C, D now because A, B, C, D doesn't have a corner at O, they all have to have corners. So you do E, O, H, D, so this entire rectangle, minus E, O, G, A. Once again, you couldn't do E, F, B, A because that doesn't have a corner at O, you have to do E, O, G, A, minus E, F, C, H. Okay, that gets us back to what we had. But because we subtracted, let me do it in blue, because we subtracted this region twice, okay, we have to add it back on to get it back to 0. Okay, so anyway guys, I hope that helps, and we'll see you in the next video.